Okay, now if you observe the previous question which we had solved, it was related to a pH diagram. Okay, so we had solved a numerical related to pH diagram, ammonia pH diagram. Now there are few numericals which you have to solve using the table method. Okay, now what is the table method? This is a extract from a main table for the given refrigerant. So here we will first see the question. What is the question given? A refrigeration machine using R12 as a refrigerant. So refrigerant over here is R12, operates between pressures 2.5 bar and 9 bar. Now in the previous problem we had seen that there, instead of the low pressure and high pressure value, a low temperature and high temperature was given. Okay, so here the temperature is not given. From this table we will understand what is the saturation temperature. So for 2.5 bar, that is low pressure, minus 7 degrees Celsius is TL, T low. And for high pressure, that is 9 bar, the saturation temperature is given as 36, so 36 degrees Celsius will be T high. Now when we calculate the Carnot COP, in that case this T high and this T low we have to convert to Kelvin. Okay, then the vapor entering the compressor is dry saturated. Now this, they are talking about which point? Can you visualize the diagram and tell me this is about which point? Point number 1. And there is no subcooling in the condenser. So this is about which point? Point number 3. Okay, so they have talked about point number 1 and point number 3. So we'll move ahead. The if the capacity of the plant is 20 TR and relative COP is 65%. Okay, so some new term is introduced over here. We have to determine actual COP and actual power input to the compressor, and properties of refrigerant are given over here. And here it is mentioned that take specific heat of refrigerant vapor as 0.67 kilojoule per kg Kelvin. Now here you need to understand, first question which arises to your mind should be, when should we use table and when should we use pH chart. Now here the specific heat value is given, meaning Cp of vapor is given. Whenever Cp of vapor or Cp of liquid is given, in that case we have to use refrigerant table. Okay, in other cases, like if you observe the question which we had solved in the previous lecture, in this question in this question it was the value of CpV or CpL was not given, specific heat of vapor or specific heat of liquid refrigerant. So whenever the CpV and CpL value is given, there we have to use table method. Now observe the tables which are available. If you open Mathur and Mehta refrigerant and psychrometric properties, you will find tables like this. Okay, so in the index you will find different refrigerants are there, like R717 ammonia, then R12, okay, R22 is there, R134A is there. So for these and for some other refrigerants, you will find the tables like this. Also, you will find the pH chart like this, okay, which we had seen in the previous session, this pH chart. So you will get pH chart like this in Mathur and Mehta book, data book, as well as you will find tables for the same type of refrigerant. Now, if you observe the table over here, see, it is not necessary that in question the table is given. They might only give you CPV value, okay, and you have to find the whatever is asked in the question. In that case, don't use pH chart. Whenever CPV or CPL is given, you have to use table method, okay. And there in table what data is given here, we have saturation temperature, this is saturation pressure, HF, Hg, SF, Sg, and specific volume of liquid and specific volume of vapor. Suffix F stands for saturated liquid, suffix G stands for saturated vapor. Okay, this is similar to the steam table. This refrigerant property table is similar to steam table. Okay, it was related, but the steam table is related to water. Okay, this table is related to ammonia or some other type of refrigerant. Now we will see, we will continue with the numerical part. So first thing is you have to identify that the given question should be solved by which method. Okay, here we have established that now we have to use table method, and here in the question itself that table is given. So no need to look at the separate table. Okay, now what we will do, we have to draw this. Before that, now we will see what is relative COP. So we will quickly revise the things. This you had studied in thermodynamics. So I am not going in detail. I had already provided you the video for this revision of the different equations. So if we have specific volume and if we have different conditions, these are the equations. Then for specific enthalpy, these are the equations which you have to remember to calculate specific enthalpy at for the different types of for the different phases of the refrigerant. Okay, here steam is written. Instead of that steam, you can replace that by refrigerant. Okay, then we have specific entropy for different types like saturated liquid, saturated subcooled liquid. Okay, then saturated vapor, wet vapor, superheated vapor. So these equations we have to use today. Then next one, this equations you understand. First equation, if you observe over here, I have written as COP actual. Now this COP actual is given by the equation Q dot A upon W dot C. Q dot A is heat absorbed in evaporator and W dot C is power consumed by the compressor. Now you observe over here that according to the pH chart, okay, this is suppose the pH chart. So 1 to 2 is compression, 2 to 3 is condensation, 3 to 4 is expansion, and 4 to 1 is evaporation. Okay, like this we will have numbering. So basically, the heat is absorbed during process 4 to 1. So H4 minus H1 minus H4, higher enthalpy minus lower enthalpy into mass flow rate of refrigerant will give us value of Q dot A. Okay, and power consumed by the compressor, you observe the equation. This is given as 10 into 3600 divided by T into EMC. So the next, so here what I am trying to suggest is the power consumed by the compressor. This is calculated using this equation. Okay, this equation we will see in the practical session. Now here EMC is called energy meter constant. So basically you know the energy meter, right? Your house, your whatever your flat is there, that each and every flat has energy meter. Okay, to find what is the energy consumption, and according to that you will get the bill. So this energy meter is attached to the compressor of a particular device so that we can count what are the impulses. Okay, so this for suppose for 10 impulse, this is the 10 impulse. For 10 impulse, what is the time in second? That time we have to substitute over here, and this 3600 basically we are converting this impulse per kilowatt hour. Here you see R is there, that R is converted into seconds over here, and this energy meter constant is 3200. uh, did you get the basic idea of this equation? This is why we are using this, because this is actual power consumption what we get from energy meter. How this formula arrives now we will see later on. Now the next type of COP is called theoretical COP. Okay, it is refrigerating effect upon work consumed by the compressor. Simply we have to take H1 minus H4 and divide by H2 minus H1 from the pH diagram. So that type of COP is called theoretical COP. So you should remember this. Theoretical COP means whatever we get from pH chart or from the refrigerant table H1, H2, H4 values, from that whatever we calculate, that is theoretical COP. Actual COP means actually we measure the power consumption of the compressor. Okay. Next one is ideal COP, or you can say Carnot COP. Okay, that is given by the equation T low upon T high minus T low, where T low and T high are the saturation temperatures in Kelvin. Okay, then we have performance index, or it is also called system efficiency index. It is given as actual COP upon Carnot COP. So this actual COP upon this Carnot COP will give me system efficiency index or performance index. Next one is relative COP. Now relative COP is basically comparison between actual COP and theoretical COP. So actual COP is this one and theoretical COP is this one. So comparison between actual COP and theoretical COP gives us relative COP. Okay, now what is asked in the question? Actual COP. So how can we find the actual COP? What is given here? Relative COP is given. We have to find actual COP. If you see the equation, what is given? A relative COP is given. Okay, here you see relative COP has been given and we have to find actual COP. So what is required to be found out? Theoretical COP. How to find theoretical COP? What is the formula? H1 minus H4 upon H2 minus H1. We have to use this equation and we will get theoretical COP. Relative COP is given. So if we multiply, cross multiply over here this relative into theoretical, we will get actual COP. Okay, so we have to find basically theoretical COP. Now, if you observe this, here we are not going to solve this question by pH chart. Okay, we are going to solve this by table. Okay, so what I will do, I will first draw the pH, TH diagram and the setup. Okay, so let me copy all the things from the previous question. Now in this question, what is given again, that point 1 that is entering the compressor, it is dry saturated, and point 3 there is no subcooling. So the same type of pH diagram and TH diagram is shown here, that point 1 is on saturated vapor, and for point 3 that is exit of the condenser, we don't have subcooling. So that has been shown on saturated liquid curve. Same is shown on the TH diagram as well. Okay, so all the four processes, 1 to 2 isentropic compression, then 2 to 3 constant pressure heat rejection in condenser from the refrigerant to the atmosphere, then 3 to 4 isenthalpic expansion, and 4 to 1 is heat absorption in evaporator. Now what we have to do, we have to find, basically our target is first we have to find theoretical COP. If we are able to find theoretical COP, then multiply it by relative COP, we can get actual COP. Okay, now in order to find theoretical COP, we require H1, H4 and H2. Okay, what are these? They are shown in the diagram. Okay, point 1 is entry to the compressor, H4 is exit of the expansion valve. Okay, and H2 is exit of the compressor, or you can say inlet to the condenser, both are same. So we have to find enthalpy of this location. So what we will do now, we will find enthalpy one by one. Okay, so for point number 1, how to find the enthalpy? Point number 1 is on which curve? What is the pressure? Low pressure value. We will write the low pressure value in the question first. What is the low pressure value given? Low pressure is 2.5 bar and high pressure is 9 bar. So I'll write down the values. Low pressure is 2.5 bar and high pressure is 9 bar. Okay, same way here the condenser temperature TC table over here. Okay, saturation temperature. So for 9 bar the temperature is 36 degrees Celsius. And TE, the pressure is 2.5 bar, so the corresponding temperature will be minus 7 degrees Celsius. So T low is minus 7 degrees Celsius. So this is T high, this is T low, 9 bar and 2.5 bar, these values are given in the question. Okay, so I have marked everything over here. Now tell me, point number 1 lies on which curve? Saturated vapor. Now point number 1 is at which pressure? 2.5 bar. So H1 will be equal to what? H1 will be equal to what? HF or HG? HG. At what pressure? 2.5 bar. This we have to use. Okay, so I'll write down H1 is equal to Hg at 2.5 bar. Now what is value of Hg at 2.5 bar? We have to check the table. So at 2.5 bar, this is specific enthalpy H and this is vapor. So here we will have Hg. So I will just write down the notations over here. This is HF, this is Hg. and this is Sg. Okay, wherever vapor is there, there we are using suffix G. So for 2.5 bar, what is Hg? H1 value is 570.3. 570.3 unit will be kilojoule per kg. Okay, now for next point. Point number 2 is very important. Understand that. Now point number 2 is in which region? Superheated vapor region. Okay, so what is the equation of enthalpy, specific enthalpy for superheated vapor region? Understand that. Okay, so specific enthalpy for superheated vapor is given as Hg plus Cpv T sup minus Tsat. So I'll write down this equation. Okay, so what is H2? H2 is Hg plus Cpv in bracket T sup minus Tsat. Now point number 2 is at which pressure? 9 bar. So whatever Hg is there, it will be for this point. Okay, for this point or for this point, what is Hg? It will be Hg at 9 bar pressure. So I'll write down Hg, this pressure will be 9 bar plus Cpv into T sup minus Tsat. Now this T sup is for point number 2 and Tsat is also for point number 2. Now what is Tsat of point number 2? Okay, whatever values we have, we will find out that. Okay, H2 is there. Now Hg at 9 bar. What is that value? 9 bar. What is Hg value? 585.3 kilojoule per kg. So what is Cp of vapor? Cp of vapor is 0.67 kilojoule per kg Kelvin. So I'll write down that value 0.67 in bracket T sup of point number 2. Now this T sup of point number 2 is not known. Okay, what is this temperature? See, for point number 2, just tell me for point number 3 and for this point what I have shown, what will be the temperature? Can anyone tell me for this point 3 and for this point? What will be the temperature? 36 saturation temperature. Very good. But what about point number 2? It will be greater than 36, equal to 36 or less than 36? Greater than 36. How you can say that? Because I'll show that. Okay, or I'll show that line. Here we will have that T sup line. Okay, this will be T sup 2 like this. So this temperature T sup 2 we don't know, which is this is the constant temperature curve on pH diagram. So this T sup line we don't know. So we don't know temperature T sup 2 value. So this is not known. So this value is not known. I'll keep this as it is. So T sup 2 minus Tsat 2. What is saturation temperature of point 2? For point 2, saturation temperature is how much? 36 degrees Celsius. So I'll write down the value 36 degrees Celsius. Okay, this is equation 1. So here, see, there is one hurdle in front of us. To calculate H2, we require T sup 2. Is this clear? Now, how to find this T sup 2? Okay, very easy. Basically, if you observe the pH diagram, process 1 to 2 is which process? Process 1 to 2 is which process? Isentropic process. Okay, it means what? Entropy of point 1 is equal to entropy of point 2, specific entropy. So we will use this to calculate T sup 2 value. This is the approach. See, in all the numericals of table, same approach you have to follow. Okay, so what I'll do now, S1 is equal to S2. I'll write that. So S1 is equal to S2. Now for point number 1, how to find S1? Point number 1 is on which curve? Saturated vapor. So this S will be what? SF or SG? SG. At what temperature or what pressure? -7 temperature or 2.5 bar. Okay, so I'll go to the table. 2.5 bar. Okay, I require SG value. What is that SG value? 4.76. So SG at 2.5 bar, it is 4.76 equal to, what is H2? Point number 2 is in which region? Point number 2 is in which region? Superheated vapor region. Okay, so we need to find H2 of superheated vapor. So what is the equation for H2? So I'll write down the same equation now. S1 is equal to H2. Okay, so H2 will be Sg but at 9 bar plus Cp of vapor log T sub 2 by Tsat 2. Now see, point number 1 is at which pressure? 2.5 bar. Point number 2 is at which pressure? 9 bar. So at the pressure, saturation pressure and saturation temperature, you have to see the property. See, T sub 2 value is greater than 36. So when I say what is the temperature of point 2, what will be the answer? What is the temperature of point 2? 36 or T sub 2? What will be the answer? T sub 2 will be the answer. But if I ask you the question, point 2 is superheated, but for point 2, what is the saturation temperature? So what will be the answer for the given 9 bar pressure? 36 degree Celsius. Okay, so either you will read at 9 bar or 36 degree Celsius. Okay, so here I have read that SG at 9 bar or 36 degree Celsius. Okay, both will give same answer. Okay, so SG at 9 bar, what is the value? For 9 bar, SG is 4.74 plus Cp of vapor. What is Cp of vapor? 0.67. Log T sub 2 is unknown upon Tsat 2. What is value of Tsat 2? Tsat 2 value is how much? 36 degree Celsius. So 36 plus 273 gives how much value? So T high is 309 Kelvin. So just we have to substitute the value over here, 309. So we can only unknown in this equation is what? T sub 2. What is T sub 2? Temperature of point 2. So we can find that once we find this T sub 2 value, substitute in this equation, we can find H2. Okay, so give me the value of T sub 2 now. So T sub 2 is equal to, what is the value? Calculate. So answer is 318.36 Kelvin. This is T sub 2. Now T sub 2 value in degree Celsius, calculate that. Minus 273, 45.36 degree Celsius. Okay, now what we can do? We know the value of T sub 2. Substitute over here, we will be able to find H2. So I'll write down, substitute T sub 2 in equation 1. Okay, so what I will get? H2 is equal to, substitute this value over here and give me the answer. What value of H2 you are getting? So H2 is 591.57, unit will be kilojoule per kg. It is specific enthalpy. So now we have found enthalpy of point 1, we have found enthalpy of point 2. Next will be enthalpy of point 3, H3. So how to find H3? See the pH diagram which we have drawn. Point 3 lies on which curve? This is which curve? Saturated liquid. So point 3 enthalpy H3 will be given by what equation? It will be equal to what? HF or Hg? HF. At what pressure or temperature? 9 bar pressure, or you can say 36 degrees Celsius temperature. Okay, so I'll write down this. H3 is equal to HF at 9 bar. Okay, what is this value? We have to see the table now. H3 is equal to HF. So for 9 bar, HF value is how much? 456.4. 456.4 kilojoule per kg. Okay, now if you see the diagram, H3 is equal to what? H4. So no need to calculate H4 again. Okay, you see during throttling process 3 to 4, enthalpy remains constant. So H3 we have found that will be equal to H4. It will be refrigerating effect. Okay, what is refrigerating effect? H1 minus H4 upon compressor work, H2 minus H1. So we'll write down the equation here. COP theoretical is refrigerating effect upon compressor work, which is H1 minus H4 upon H2 minus H1. So substitute all the values. What is H1? H1 is 570.3 minus H3 equal to H4, which is 456.4 divided by H2 591.57 minus H1 570.3 kilojoule per kg. So what answer of COP you are getting? COP theoretical. So COP theoretical is 5.35. But what is asked in the question, that we have to see now. What is asked? What is the first question? We have to find actual COP. So I'll write down the heading, calculation of actual COP. Okay, so first question is actual COP. How to find actual COP? We have to use equation of relative COP. Okay, so relative COP is actual COP upon theoretical COP. Relative COP is equal to actual COP upon theoretical COP. What is relative COP? Given in the question value, relative COP is 65%. Okay, so relative COP is 0.65. See, you have to observe this, that actual COP value is greater than 1 for refrigerator or heat pump. Theoretical COP value is also greater than 1. But if you consider the relative COP, it is basically what? Percentage. Okay, this is given in the form of percentage. Even though here it is written COP, this is basically the percentage. So understand that point. So relative COP is 65%, so 0.65 equal to actual COP we have to find, and the theoretical COP we have found out already. What is that value? 5.35. So what is value of actual COP? 3.48. So this is answer number 1. Okay, now what is the next question? Okay, see the next question. Actual power input to the compressor. Okay, now power input to the compressor, how you have to find this? Mass flow rate of refrigerant into H2 minus H1. If we do this, we will get the power consumed by the compressor. Okay, now what we will do here, the capacity is given, okay, 20 TR. So we will use this equation. So we will use Q dot E equation or heat absorbed equation in the evaporator. So I'll write it down. Next is sub question number 2. What we have to find? Actual power input to compressor. Okay, how to find this? We will first find mass flow rate of refrigerant. How to find that? See, we can directly use the equation of refrigerating effect. What is the Q dot E value? Heat absorbed in evaporator, it will be equal to mass flow rate of refrigerant into refrigerating effect. Okay, what is refrigerating effect? Refrigerating effect is H1 minus H4. Okay, so m dot R into H1 minus H4. Now what is the Q dot E value? Ha, bolo. See what happens now, understand. Here we have to find actual power input to the compressor. Okay, so what we are finding right now, first step will be what? We have to find mass flow rate of refrigerant. How we can find this? Wherever data is available. Where the data is available, it is given in the question, right? What is given? Heat absorbed or the capacity of the plant is 20 TR, and this capacity means where is the heat absorbed? Heat is absorbed in which device? Evaporator. So we are using the equation of heat absorbed in the evaporator to find mass flow rate of refrigerant throughout the vapor compression refrigeration system. Okay, by taking that mass flow rate, we will find power input to the compressor. Okay, there we will use m dot r H2 minus H1. Okay, but we require m dot r, so we are first calculating m dot r, mass flow rate of refrigerant. Did you understand now? So m dot r we have to find. So q dot e is 20 TR, right? So 20 into 3.5 equal to mass flow rate of refrigerant into H1 minus H4. What is the value of H1 and H4? We'll take the values from here. These are the values. So calculate and give me the answer of mass flow rate of refrigerant. So m dot r, mass flow rate of refrigerant, is how much? 0.614 kg per second. Now here you shouldn't write kg per second per TR. Why? Because it is given that it is 20 TR. So you cannot use per TR unit over here. Like we had used in the case where it was given that calculate the mass flow rate of refrigerant per TR. In that case we had taken here 1 TR and we calculated this kg per second and we wrote here kg per second per TR. So here total 20 TR is mentioned in the question. So we have found mass flow rate of refrigerant. Now what will be the next step? We have to find actual power input to the compressor. Okay, so what will be power input to the compressor? W dot C. It will be equal to m dot R, higher enthalpy H2 minus lower enthalpy H1. Okay, we have to see the compression process on pH diagram. So what is the compression process over here? 1 to 2. So higher enthalpy is H2, lower enthalpy is H1 into mass flow rate. See, if you do only H2 minus H1, that will give you specific work consumed by the compressor in kilojoule per kg. If you multiply this by m dot r, you will get kilowatt power consumed by the compressor. Okay, so work is getting converted into power if you multiply this work by m dot r. That is the logic over here. So I'll multiply this and find out the answer. So m dot r is 0.614 into H2 minus H1. Values we already have. So here this value is H2 minus H1. So calculate and give me the answer. So W dot C is 13.071 kilowatt. This is the power consumed by the compressor. So in this way we have completed with this question. I'll quickly revise this what we have done in this problem. See, R12 refrigerant is given. So if this the specific heat of refrigerant vapor is given. So if this data is given, we understand that we have to use table. If this table is not given, then you have to refer Mathur and Mehta data book, and from that data book you have to see and 9 bar. Okay, let me check if I have R12 refrigerant data table in this file. Okay, let me check R12 का है क्या मेरे पास रहेगा तो हम लोग वो भी देख लेंगे. This is ammonia. Here you observe. Can you see this table number 5? This is R12 refrigerant. We had pressure value as 2.5 bar, low pressure, and high pressure value as 9 bar. Remember this value. Now I'll go to R12 table. Okay, this is R12 table. So this is the pressure given in bar. Okay, we require how much pressure? 9 bar pressure. So here you have to see 9 bar pressure. Here we don't have exactly 9 bar pressure. Okay, see here, this is 9.14, this is so 9 bar will be in between over here somewhere. Okay, so that you have to understand that 9 bar will be over here. So by interpolation you can find, or for 9 bar what is the corresponding temperature that you can get, and from here also you have to do interpolation. Now you observe there, according to that table, 9 bar pressure gave us how much saturation temperature? 36. So there is slight change in the table values which is given in the exam. In the if you see the table which is given in the question, therefore it is given that for 9 bar pressure 36 is the saturation temperature. But if you observe this table, there is certain change over here. Okay, that is okay. See, if the table is given in the question, you have to use that table. If the table is not given, you have to use the table from Mathur and Mehta book. Okay, that you have to remember. So this will be around here somewhere you will have that 9 bar, and 2.5 bar is at this one. Here you will find in between over here 2.5 bar. Now they have rounded off the value for 2.5 bar. They have given the temperature as -7. Okay, but the -7 temperature is for 2.4355 bar in actual case. So certain rounding off they have done in the given question. So once we have to see the table, given table, then whatever is asked we have to find. Okay, so basically we have to find the enthalpy values. Enthalpy how we have found? Since this is standard vapor compression, point 1 is dry saturated, H1 is given by Hg at 2.5 bar. H2 कैसे आएगा? H2 will be Hg at 9 bar plus Cp of vapor into T sub 2 which is unknown minus T sat 2 which is 36. So then what we did, T sub 2 was unknown. So we equated S1 equal to S2. Why? Because the process 1 to 2 is isentropic compression. So S1 is what? Sg at 2.5 bar, and S2 is what? Sg at 9 bar plus Cp of vapor log T sub 2 upon T sat 2. So from there we got T sub 2 value. we substituted in H2 equation, we got H2 value. Then H3 is what? H3 is HF. Why? Because it is on saturated liquid curve. HF at 9 bar and H3 is equal to H4. Then simply we have to use the theoretical COP formula to find the theoretical COP. Okay, then we have used a relative COP equation to find actual COP.